Hello, check. Alright people, I believe we are live. Yes, welcome back to the Alchemist by Unacademy. My name is Pahul and if I'm audible and visible, please write here in the chat box, you know the drill. Yes. और बताओ दोस्तों, how's it going on? I know I told you I'll give the new setup today, but एक connector आना बाकी है. There's one connector that's pending. So once that comes, I think I'll be able to change the setup. But anyway, doesn't matter because what matters is what we will study. So today we'll do periodic properties, shielding effect and screening effect mainly. We'll try to see the application of it where we can. Very nice application. But before that, let me make a few announcements, okay? First announcement is that we have the Unacademy's Combat Scholarship Test. This happens weekly, okay? It happens every single week. It happens every Sunday, all right? And every Sunday, what you can do is you can experience the competition because a lot of students take this test every single week. So, in case you also want to do that, if you want to practice using the Unacademy Combat Test, then you enroll in it using the code Pahul, okay? And it's a scholarship test, so you can win a scholarship in case you perform well. You have a QR code to scan in case you want to enroll right now. Fine, the code you use is Pahul. Then people, what is wrong with this board? The touchscreen was working, but apparently doesn't want to change slides. Why? Okay, anyway. So, yeah. I'll change it from there. Anyway, so another announcement is that a new price hike is coming very soon. This is something that the team has told me I have to tell you. Yeah, that in case you want to enroll, then the old prices are effective till 31st July, which I will show you right now. Then there will be a price hike. So in case you are willing to make an investment in Unacademy, then right now is a good time to go for the Plus subscription. What happens here is that you have India's best teachers. Okay, we have unlimited number of batches, infinite number of teachers. Yeah, and you can join any teacher, any subject, any batch you want. We will not throw you into a specific batch. You can join the batch of your choice wherever you want. Fine. This is the beauty because we don't throw you into top batch or 7th batch or 10th batch, nothing like that. You can learn from any teacher, all the courses that the teachers run. The teachers themselves provide you a lot of study material, a lot of DPPs. Weekly tests are a part of the Unacademy Plus subscription, okay? So these are the prices over here as you can see, okay? For 1 year if you have to subscribe, it's less than 3,000 a month, okay? 2,888 likha hai yahan pe. 2,888 per month, alright? So in case you want to enroll, you can use the code Pahul to get the best possible price, maximum possible discount, okay? And we have another offering that is known as the Iconic subscription, where you get the personal mentorship apart from all the benefits of the Plus subscription, fine? So everything and personal mentorship is your Iconic subscription. You get a lot of other good things in the Iconic subscription. So if you're really serious about the preparation, then you might want to go for the Iconic subscription. Again, the prices are a little higher than the Plus subscription, but that's obvious because you're getting a personal mentor. Again, the discount code you use for the best prices is Pahul. And if you find anything inappropriate in the video, you can report it from the link given on the top of the description box down below. Okay? So we had discussed the periodic table. Did you check out ptable.com website? Joker, I know man, the camera angle is slightly weird, but that's because I was trying the old setup, so I had to remove, I was trying the sitting down setup, I had to remove everything, then set it up very quickly for the class. So if the camera is a little tilted, don't worry, just work with it today, okay, thank you. But yeah, so I hope you checked out ptable.com. If you didn't, make sure you do that today. Fine. So we talked about the configurations of S block, P block, D block, F block. Yeah. And this was your homework, general configuration of the F block. Can you guys please tell me in the chat box what's the general configuration of the the F block? Yeah. Now let's move forward and let's straight away dive into some questions. Let's do this question. What would be the IUPAC name for the element with number 120? See what happens is, when new elements are discovered in the laboratory, there's a lot of politics behind it. Russians want to name it on the name of a Russian scientist. Germans want to name it on the name of a German scientist. Americans want to name it on the name of an American scientist, so on and so forth. So to avoid all of that politics, there are tons of meetings that happen in IUPAC. Yeah, and then eventually they take a decision of, okay, this is the name of the element. But by the time a name is not given, we assign a temporary name to these elements. Okay. So how to write the name for 120? 120 के लिए क्या name लिखेंगे? Just look at this table. Okay. 120 के लिए the name will be un by nil and end में you add em. Okay. Un by nil em. Un by nilium. So this simply represents that the atomic number is 120. And how to give a short form to this? What's the short formula? UBN. Okay, short formula will be UBN. This is not that useful, but telling you because sometimes they might ask this in NEET or board examinations. Okay, this is very simple, given in the NCERT as well. This table, you're like, sir, will they give us the table in the board examination? No, they won't. So you have to remember it. But I don't think remembering it is very difficult. It's simple. Nil, un, bi, tri, quad, pent, hex, sept, oct, n. Very common. Yeah. तो कर लेना यार याद एक बारी. Please make sure you remember it somehow. And then moving on to further questions. चलो ये करते हैं. So these questions will help us revise whatever we know till now in periodic properties, and it will help us go forward as well. Fine. तो चलो ये करते हैं. First question, who gave the triads? Yeah, this is something that you've done in your previous classes as well. 9th, 10th class में किया हुआ है. Okay, Prasanna is asking, sir, when is that Unacademy class for doubts session? Today at 9:30, bro. Just open my profile at Unacademy. The link for that will be in the description box down below and enroll for it. Okay? Chalo ji. Dobereiner's triads, everyone knows this, yeah? Then, according to Moseley's experiment, the atomic number is directly proportional to, it is directly proportional to the root of frequency of the X-rays that are emitted. I had given you a link as well to read about, isn't it, for Henry Moseley's experiment. So, root of frequency, fine. Then, all of the S block elements are non-metals, halogens, metals or chalcogens. Very simple. All of the S blocks elements are metals. Obvious, right? Then the next one, what would be the temporary name for the element with atomic number 198? Un, N, Oct, Em. Yeah. And the symbol will be UEO. Isn't it? Unanoctium. Rishi is giving the answer in the chat box. Very nice. Yeah. So, Unanoctium, UEO. This is also done. Great. Then, which one is more metallic, silicon or germanium? Which one is more metallic, silicon or germanium? Where are silicon and germanium on the periodic table? Carbon family. Can silly Germans snatch lead? That's how you can remember, okay? Can silly Germans snatch lead? And there's one more way to remember it, and that is C Ge Sun Punjabi. That's how I remember it. C Ge Sun Punjabi. That's just my own mnemonic that I've come up with. Helps me remember it. Fine. So when you go down the group, metallic character increases. Yes. So which one is more metallic? Germanium is going to be more metallic. Fine. Then the next one is sort in terms of reactivity. Fluorine, bromine, iodine and chlorine. Fluorine, chlorine, bromine, iodine and astatine. Yes, these are your halogens. Now, in terms of reactivity, which one is higher, which one is lower? Okay, I'll give you a hint. First of all, reactivity for different things are different in different reactions. In some reactions, iodine might be more reactive. In some reactions, fluorine might be more reactive. But more generally, think about non-metallic nature. Fine. Think about non-metallic nature for the reactivity of these halogens. See, as you go down the group, the metallic character increases. As you go up the group, non-metallic character increases. Halogens tend to react as non-metals. Since fluorine is the most non-metallic, this is going to be the most reactive. Okay, then chlorine, then bromine, then iodine. ठीक है? So this is a general idea. It differs for different reactions. When you will do these reactions in, let's say, organic chemistry or inorganic chemistry, then you will understand it better. But in general, the reactivity of fluorines and fluorides is much higher than the rest. Okay, chalo. Then, next one is, give the electronic configuration and periodic table position of Z equal to 74. ये कैसे करेंगे? How would you approach this question, people? How would you approach this question is what you need to tell me. इसको approach कैसे करोगे ये बताओ. कैसे अप्रोच करोगे बताओ. व्हाट्स योर टेक्निक ओवर हियर. Electronic configuration, will you start counting one by one, etc., etc.? See, I'll give you a hint. What you should do is you should try to remember the atomic numbers for all the noble gases. Okay, what are the noble gases? Helium, neon, argon, krypton, xenon and radon. Yes, helium, neon, argon, krypton, xenon and radon. ये है. Now what you do, you try to remember the atomic numbers of these. याद है? Huh? Do you remember the atomic numbers of these? Very simple. Okay, this is 2, 10, 18. पहले तीन हो गए. 2, 10, 18. Then 36, 54. 2, 10, 18, 36, 54 and 86. As simple as that. Just try to remember it. Okay. Just try to remember these numbers 2, 10, 18, 36, 54, 86. How do you remember it? It's totally up to you. Whether you cram it up or somehow relate these numbers with each other, whatever you want to do, you do it. But 2, 10, 18, 36, 54, 86, this is how you remember the noble gases. Now you have a sense of reference over here, isn't it? You have a sense of reference over here, and 74 is what? Radon minus 12? Yeah. Radon minus 12 is 74. So you have to go 12 spaces behind radon. Will that help? Will that help? You just have to go 12 spaces before radon. Help करेगा कि नहीं करेगा? It should help, right? Fine. So once you do that, you will figure out that 74 belongs to tungsten. Okay, 74 belongs to tungsten. So a lot of you would be like, sir, how do I remember the periodic table? Remember the periodic table using mnemonics, as I've told you in the previous class as well. Just have a look at mnemonics for periodic table online. You'll be able to remember the entire thing. You'll be able to reproduce it on paper in less than 2 minutes. It is possible. ठीक है, चलो कर लेना. Tungsten is something that you guys can figure out on your own, I'm pretty sure. Next question. In the fourth period of the periodic table, how many elements have one or more 4d electrons? This is a very good question. In the fourth period of the periodic table, fourth period kaun sa hua? You start with hydrogen. Yeah, 1, 2, 3, 4. So now after potassium, you have what? Calcium. And then you have the transition elements. So we have scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. These are your transition elements. Fine. Then furthermore, ठीक है, अब बाकी डाल दो गैलियम, जर्मेनियम, etc., etc. Fine. So you keep putting these things in these. You have to tell me how many elements have one or more 4d electrons. In the chat box, everyone, can you read Rishi's message? Huh? Chat box mein, Rishi has written something very interesting. Can you please read Rishi's message? My dear friends, electronic configurations, this is what? This is 4s1, this is 4s2. Yeah. These are 4s2 3D something something something, isn't it? This is entirely full of 3D electrons. No 4D. 3D नहीं होता भैया, 4 क्या 3D होता ना, 4D नहीं होता यहाँ पे. It's just 3D. Fine. So over here you have 3D electrons. Then from here onwards you have 3D10. You will have 4p getting filled over there. 4D will get filled later. So the point is, answer to this question is 0. Okay? The answer to this question is 0. None of these have. Okay? None of these have 4D electrons. Good question, right? अच्छा question है. Kavita, can you please refresh? I have once again fixed the focus. Yeah, I have once again fixed the focus. If it's still a problem, can you increase the video quality from your side in the live stream? Chalo, next question. If the off-bow principle had not been followed, very nice question. If the off-bow principle had not been followed, what group would calcium be in? What block would calcium be in? Okay, you do not follow the off-bow principle. See, what is calcium? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Yeah, this is what calcium is. But why am I not filling the 3D over here? I am not filling the 3D before the 4s because 3D has higher energy, and that is told to us by off-bow principle. Yeah, off-bow principle tells us, fine. If I do not follow the off-bow principle, I would do 3D2, 4s0, isn't it? So this is not according to off-bow. Yes. So last electron कहाँ गया? D में. Therefore, it would be a part of the D block. All right. Laksa Prasadan, bro. Whenever I speak Hindi, I am going to repeat the same sentence here or there in English as well. So if you can't understand Hindi, don't worry too much about it, bro. All right. Punarvas, yeah, man. I'll get that done very soon. Okay, chalo. Next one, please. Lanthanum. Lanthanum has atomic number 57 and it's a member of what? I've told you in the previous class. Everyone, quickly tell me what's the answer. Icon Umashankar, thank you so much. Rishi, very nice. Sarthak, very nice. Rishi and Sarthak have been attending my classes regularly. Good job. A lot of you have, but they've given the correct answer quickly. Everyone else, do you remember what did I tell you in the previous class? Lanthanum and actinium themselves belong to the D block because their final electron goes into the D orbital. Okay, fine. So this actually belongs to the D block, not the F block, because its last electron goes into the D orbital. Okay, fine. ठीक है जी. You have to think about the electronic configuration. Lanthanum is, if I have to tell you, lanthanum is simply xenon's electronic configuration, then 6s2, 5d1. Okay, it's a 5d1. The last electron goes into a D orbital. Okay, last electron goes into D orbital, therefore it is a member of the D block, not the F block. F block starts after lanthanum. It is drawn with the F block most of the times, just to show you that, okay, this is where the F block is starting from. Technically, it is a part of the D block itself. Please don't make this error. Okay? Chalo. Last one. The electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p3. What is the atomic number of the element which is just below the element that we've just mentioned? P3. If you've studied the atomic, if you've studied the periodic table properly, you would know that P3s belong to nitrogen family. Yeah. And you would know, if you've attended the previous class carefully, this is a 2p3. So this is a 3p3. This is going to be a 4p3. Isn't it? Arsenic is going to be 4p3. Yeah. So 3p3 ke niche kaun sa? What's below the 3p3? Below 3p3 you have 4p3 and that is arsenic. So first of all, we are talking about arsenic. Yeah. Then what's the atomic number? Now you can count. That is also fine. Otherwise, what trick did I tell you? Yeah, this is how you can do it. 2, 10, 18, 36, 54, 86. Yeah, 36, 35, 34. This will be 33. Done. Yeah. You could count from here as well. You could count from phosphorus, add electrons and get to 33. Or you could do whatever I have done over here. This is also a way to approach it. A different way. Fine. Kavita is saying, in my college they started chemical bonding and I'm following your classes. I'm a bit late. Kavita, you should read the NCRT's chemical bonding chapter. Yeah, it'll help you with your college classes as well. And anyway, it's going to be a homework from my side for you when you do chemical bonding. So start reading it. Okay, fine. Done, people? This is awesome. Great. So we have done a lot of questions to revise things as well. And before we move forward, let me remind you that I am taking a very nice counseling and doubt session for all of you guys. Okay, it's an open counseling and doubt session which will happen on Unacademy's platform for free. It is going to happen at 9:30 today. And it's a 2-hour long session. You can join at any point of time, ask your question, get your answer, leave. Okay. That's how the session works. It's an open session. So in case you want to join that, please follow my profile at Unacademy. The link will be in the description box down below. You open the description box, it says follow Pahul Sir at Unacademy. Just open that link, okay? You will be able to see all the classes that I'm doing over there. Go to my free classes and you'll be able to see today at 9:30 there's a session. If you want me to show you where it is, I will show you in some time, okay? Chalo. So it's for all of you students who are targeting JEE 2022 and who are in 12th class. Fine. A lot of you are here for 11th class. 11th class session happened yesterday. You can check that out. If you want, you can join today's session as well. You will also get to know a lot of things. But if you're in 12th class, then today's session is even better for you. Chalo. Now let's come to screening effect or shielding effect. Okay. For understanding screening and shielding effect, let's try to visualize something. Imagine you are in a concert. Imagine that you are in a concert. Okay? Have you ever been to a concert, people, or a show? If not a concert, then some show maybe. Yeah? Fine. Devraj, what happened, bro? People, I'm teaching, so it's difficult for me to focus on the board and on the chat box and on the camera. If I had 3 eyes which moved in all 3 directions, then separately, then yeah, I would be able to focus. But if I'm not able to read some of your messages, please don't worry. So what happens in a concert is that the stage performer is performing over there. Yeah, somewhere in that area, the performer is performing. And if there's a lot of crowd and then you're standing, yeah, you'll be doing this just to see the concert. Yeah. Some people try to climb some stairs or something to see the concert. Okay. So, because there are people in front of you, it's difficult for you to experience the concert properly. Happens. The more are the number of people in front of you, the worse will be your concert experience. But the closer you are to the stage, the more you will enjoy, because this performer is going to be right in front of you. Yeah. Imagine you are in the front row. And if you are in the front row, you'll be like, ah, nice. This performance is good. Yeah. Cool. So what's happening is that the crowd in front of you is shielding you from experiencing the concert in its full glory. Isn't it? You want to experience the performance, you want to experience the concert, but the crowd in front of you is shielding you from doing that. Or I can say, in just different words of English, that the crowd in front of you is screening the concert. Yeah, they're not allowing you to see the full thing. They're just screening it a little. Screening and shielding, basically the same thing. Okay, they're just screening the concert a little, so you are not able to experience it 100%. Maybe you're able to take, let's say, 70% of the visual. Got the idea? The same thing happens for electrons as well. First of all, the idea is that screening effect or shielding effect is generally defined for the valence electron. Okay. So, same image I'll draw over here. This is the nucleus. Yeah, nucleus has what? It has a lot of positive charge. So, nucleus is a positive sphere you can imagine for now. And for the simplicity, sake of simplicity for now, that you imagine you are over here on this electron. And there are lots of electrons, yeah, in the lower shells. Okay, first shell, second shell, you are sitting in the third shell, let's say. Yeah, lots of inner electrons. So what's happening is that because of these inner electrons, you who are sitting outside in the valence shell, in the outermost shell, if you're sitting on this electron, you will not be able to experience the full positive charge of the nucleus. You will not be able to experience the full glory of the positive charge, because it is shielded from you by the electrons that stand in the way. Isn't it? Yeah. Kavita is saying, should I study periodic properties or chemical bonding? Study both at the same time. You are a human who's more than capable of doing so. Sorry. You're not a machine. Everyone who's here, you're not a machine. Okay? You're not a juicer, mixer, grinder, or an orange juice maker where I put only one orange and then you'll process that orange. Then I put next orange. Then I put the next fruit. No. You are a human. You are capable of doing multiple things at the same time. Please use your brain and focus on periodic properties and chemical bonding at the same time. I'm teaching periodic properties, learn this. Chemical bonding going on in your college, learn that as well. Great. Harish is saying, sir, screening effect and inert pair effect are the same. No, they are not. We'll learn about that later. Fine. Kavita is saying, time is not sufficient. Kavita, just a humble reminder to you that I was also in the same phase of preparation back in 2009. It is possible to manage. Okay, it is possible to manage. Chalo, so screening shielding effect, this is what we have. Because of inner electrons, you are not able to see or experience the nuclear charge properly. Fine. You are not able to experience the nuclear charge properly. So, this is the definition. This is a bookish definition. If you want to write it, you can write down. The decrease in force of attraction between the nucleus and the valence shell due to the presence of inner shell electrons is called screening effect or shielding effect. Please write it down. Okay. And Kavita, I'll give you one suggestion. See, you are attending this class. That's good. Make notes right now. You're attending classes in school. Okay, listen to those classes. When I'll teach chemical bonding, you can make notes of then. And before sleeping, you just read chemical bonding chapter from the NCERT, just like that. Just for fun. Read it from the NCERT. Trust me, that is more than enough for now. Okay? I'm sure you can manage. There's a person in the chat box who says, sir, I want to study, but I always get distracted and my focus is very less. What to do? Bro, first of all, focus on what's going on in the class rather than something else that's going on in your mind. Second of all, there's a 1-minute video that we released today on the same thing that you're asking. Just have a look at that. Himanshu, you can, but depending on someone is not a good idea. I would prefer that you do a lot of self-study as well. Okay? But yeah. Chalo. लिख लिया सबने? Did everyone write it down? If you need more time, you can pause the video over here to write it down. Let's go forward. Let's read it. This is something that you've written down already. Great. What is total nuclear charge? Force of attraction to all electrons because of the nucleus. See, what is total nuclear charge? Total amount of positive charge inside the nucleus. So, you have a nucleus. Yeah, you have a nucleus. Okay. And let's say this is a beryllium nucleus. Nucleus of beryllium. How many protons does the beryllium's nucleus have, people? 4 protons. Beryllium. Okay. Fine. So 4 protons are over here inside beryllium. Very nice. So the total nuclear charge of the beryllium nucleus is, you can say, +4. This is your total nuclear charge, TNC. Fine. But if you're sitting in the valence electron and there are some inner electrons as well, then will the valence electron be able to feel +4 charge? No, because the inner electrons are shielding it. Yeah, it won't be able to feel the entire +4. It will be able to feel something less than the +4. That is known as the effective nuclear charge. The effective nuclear charge is the net positive charge. Okay. Yeah, it is the net positive charge experienced by the valence electrons. Fine. Let us say effective nuclear charge is denoted by Z star. What is Z star? It's just how I've written effective nuclear charge. Effective nuclear charge is Z star. Okay. ठीक है. So Z star यहाँ पे लिख दिया. Fine. तो ये थोड़ा सा misprint है. I'll write it again. I'll write this entire thing again. So your effective nuclear charge will be equal to total nuclear charge minus sigma. What is this sigma now? Sigma is just a quantification of the shielding that the valence electrons are experiencing. This is just shielding put into mathematics. Yeah, this is known as the screening or shielding constant. Okay, this is known as the screening constant or shielding constant, and it is different for different elements. Fine. It is different for different elements, and there is a set of mathematical rules that is known as Slater's rules, by which you can give this an approximate number as well. There is a set of rules called Slater's rules by which you can give this a specific approximate number, but those rules are not in the syllabus. If anyone teaches you, you can see it, but it's not in the syllabus. It's not necessary. You can do a self-study on it. I would suggest that you do so. After the class, look for Slater's rules on Wikipedia. You read them, you get a brief idea of what that is. But in the examination, it's not useful. Therefore, we will not dive into it that much. Fine. Fine. So Z star is equal to Z minus sigma. Sigma is the screening constant. Okay. And it differs for different elements. We'll talk about it qualitatively, not quantitatively. We'll talk about it in terms of less or more. We won't say what is the exact number. It's not important. Fine. So sigma is the screening constant. More is the screening. More will be the screening constant. Lesser will be the effective nuclear charge. Yeah. the effective amount of the concert that you're able to see is going to be lesser than the total concert that's going on. If ever you're confused in shielding effect, just think of the concert. Okay, fine. Chalo, badhiya. This is done. So, what are the factors that affect the screening constant? How do you think about the screening constant? What are the factors that affect the screening constant? देखो, बड़ी simple सी बात है. It's very simple that if you have more inner electrons, there will be more shielding. Yeah. If you have more inner electrons, more shielding. If there are more people standing in front of you, there will be more shielding. Yeah. So, more inner electrons implies there is more shielding constant, as simple as that. Fine. More inner electrons, more is the shielding constant. Very obvious. Then, the second thing is very interesting, and it is the shape of the orbital. It's very important for us to understand this. And to make you understand the relevance of orbital shape with the screening, I will give you a certain visualization. Ready? एक visualization करेंगे. We'll do a visualization, and I'm pretty sure that will help you understand. Imagine that the nucleus is like the sun. Okay? Imagine the nucleus is like the sun. It's radiating its sunlight in all directions. Yeah. So, similar to the nucleus. Nucleus is radiating its positive charge, yeah, positive electrical field in all directions. So, sun is doing the same with heat. Fine, heat and light. And let's say you are sitting over here, somewhere far away. This is you. Fine. ये आप बैठे हो. You are sitting over here. On a cloud, which is an electron. Okay. So, imagine the electrons are like clouds. Okay. Imagine the electrons are like clouds. Fine. Now, reminding you, what is an orbital? What is an orbital? An orbital is essentially a space, a three-dimensional space, where there's a very high probability of finding the electron. Isn't it? You cannot pinpoint the electron. That's because we have the Heisenberg's uncertainty principle. We don't know exactly what the electron is doing. But we know that it's in the 2s orbital, okay, so it's somewhere in this space. We know it's in the 3p orbital, so we know, okay, it's somewhere in this space, so on and so forth, yeah? Fine. So, think about the s orbitals. S orbital electrons, okay? S orbital will look something like this. It's a spherically symmetrical orbital that surrounds the entire nucleus. So, if there's an s electron, it will be present, say, somewhere in this space. Somewhere in this space. Imagine this to be a cloud. Imagine this to be a cloud. Okay. S electron will be somewhere over here. So this is the S electrons cloud. Fine. So because there's a cloud that is almost everywhere around the sun, it's spherically covering the sun. I am pretty sure you realize S electrons will have a lot of screening effect. You're not able to experience the sun properly because there's a cloud around it, yes? Because the cloud is spherical in shape. Because of its spherical nature, it's shielding the sun very well. Yeah, you might get a little bit of sunlight because clouds are not opaque. Yeah, they're translucent. But the thing is, since the cloud encompasses the entire sphere, it's going to shield the sunlight in a very good manner. Fine. So the shielding effect of the s orbital electrons is very high. If the inner electron is a 1s or a 2s or a 3s, then it's going to have a very significant amount of shielding effect. Okay? ठीक है, ये हो गया s orbital electron. Then the next image, let's think about the p orbital electrons. Okay? What will the p orbital electron cloud look like? P orbital electron cloud will look something like this. Yeah? p orbital electron cloud will look something like this. But do you realize that there are two empty spaces, the nodal plane? Yeah, you can see the sunlight from here very easily. If you move and see the sunlight from here, or if you see the sunlight from here, you can see it very well. Yeah, there are two spaces in the p orbital from where you can see the sunlight very well. Yeah, so p orbital, since it has this space and this space because of its nodal plane, it's going to show you lesser screening effect than the s orbital. Yeah, now if we think about the d orbital electron, if we think about the d orbital electron, there's going to be even more space, right? Because the d orbital electron will look something like this. Yeah, this will be the d orbital cloud. So over here, I'm pretty sure you realize there are 4 spaces from where you can see the sun properly. Yeah, there are 4 spaces from which you can see the sun very easily. So this is going to have lesser screening effect than the p orbitals. And look at the f orbital. Yeah, there are so many spaces from where you can see the sun. Yeah, कहाँ से sun नहीं देख सकते आप? You can see the sun from everywhere over here. Yeah, so f orbital electrons in fact have a very poor screening effect. Okay, Rishi is saying, do radial nodes matter? No, angular nodes matter. Fine. So more electrons, more is the screening constant. Orbital shape mein s orbital electrons show you more screening than p orbital electrons, show you more screening than d orbital electrons, show you much more screening than f orbital electrons. F orbital electron screening is in fact very poor. Remember this. D orbital is poor screening effect, F orbital is very poor screening effect. So later on in this chapter and in the rest of inorganic chemistry, we will keep reminding ourselves of this fact that F orbital electrons have very, very poor screening effect. Okay. Rudransh, yeah, pretty much. Tanmay, what's up, man? Jaideep is saying, sir, I have exams now but can't concentrate. Help me, sir. Jaideep, just take a break for half a day and then come back to it. I think you need a small break. ठीक है जी, और बताओ. People who are asking, why did I join Unacademy? See, I have told you so many times earlier as well. The very simple answer is I just wanted to try something new. No other reason. Okay. Is it a good decision? Is it a bad decision? You decide. I took my decision. Fine. And I just wanted to experience some change. That's essentially the reason. There's literally nothing else. Icon, chalo, thank you so much. Nice. This is done. Screening constant. Okay, over. Great. Fine. Finish. Let's move forward now. So, instead of talking about the general trend of screening effect, this is not a very good idea to discuss the general trend of screening effect. What we should discuss is in fact the general trend of effective nuclear charge. We have to discuss the general trend of effective nuclear charge when we go first of all from top to bottom and when we go from left to right. Let's discuss top to bottom first. It's very simple. Okay. When you go from top to bottom, your valence electron is moving away from the nucleus. Yeah. I know you are increasing the protons in the nucleus as well, but since you're going so away from the nucleus, you don't feel the nuclear charge. Yeah. Effective nuclear charge, of course, depends on the distance as well, right? So first of all, yeah, nucleus is over here. You are moving out and then you are filling more electrons in the middle. Okay? So when you go down a group, when you go down in the periodic table, since you're moving away from the nucleus and you're putting more and more electrons inside your path and the nucleus, yeah, inside you and the nucleus, I would say between you and the nucleus, yeah. Therefore, when you go down the group, effective nuclear charge decreases. Okay, when you go Down the group, effective nuclear charge decreases. I don't know why I'm feeling so thirsty today. DMK is saying is latest rule required? Not really, man. If you want to do a self-study on it, you can and you should, but otherwise fine. Gangadhar, that's great, man. So, down the group, effective nuclear charge decreases. Now, if we go from left to right, things are very interesting. If we go from left to right in the periodic table, what happens is the valence electron is being put in the same shell. Yeah. For example, boron, यहाँ पे इनके लिख देंगे configurations. Boron is a 2p1, this is a 2p2, this is a 2p3, 2p4, 2p5, isn't it? Do you realize that the extra electron that you are putting, it's being put in the same subshell? It's being put in the same subshell. A visualization of this could be that this is the nucleus. Okay, let's say you have just for visualization one positive charge, and this is the shell where you have one electron. Yeah. Now the next electron you put is being put in the same place, one more proton. Same place, one more proton. Same place, one more proton. Yeah. See, in a concert, if people are in front of you, they disturb you a lot. If people are on this side and this side, they disturb you because they're creating their own noise. Yeah, you're not able to listen to the concert properly maybe because they're creating their own noise. But you're able to see the concert properly, isn't it? Same thing over here. If this is you, yeah, if this electron is where you are, the other electrons will disturb you a little because you will face some repulsion from this electron, which is in the same subshell. Yeah, but still you will be able to experience the nuclear charge pretty well because they're not in front of you. Fine. So, because when you're going from left to right, you are adding the electrons in the same subshell. You're adding the electrons in the same subshell. The protons are increasing. Therefore, what happens is that from left to right, the effective nuclear charge increases. Okay, in a certain period, when you go from left to right, the effective nuclear charge increases. Because you're not putting more distance between the nucleus and the electron, it's being put in the same shell. More protons, more effective nuclear charge. Right? Tanvi, first of all, try to search for that on YouTube, you will find it. Second of all, on this channel, we'll do it soon. We'll do it after this chapter is over. Coolio, Chun IIT bro. Just don't find the time to do that, man. Chalo ji, general trend of effective nuclear charge done. So if you understand the general trend of effective nuclear charge, you understand everything. Okay. If you understand what is effective nuclear charge, what is the general trend of effective nuclear charge, you literally understand everything that is there to be understood in periodic properties chapter. Everything depends on effective nuclear charge. That's it. Okay. Badhiya. This is done. Very nice. Now, let's try to think about the application. Okay. Let's try to think about a very nice application of the effective nuclear charge. It's interesting to note that fluorine's atomic radius is 64 picometers and sodium's atomic radius is 186 picometers. Okay. Let me show you where they are in the periodic table. Quickly, let me show you where they are in the periodic table. Okay. So basically you have fluorine and you have sodium over here. Yeah. Let's just write the electronic configuration. It's better for us to understand. So this is a 1s2, 2s2, 2p5 species. Okay. And this is a 1s2, 2s2, 2p6, 3s1 species. Yes. So fluorine, yeah, it has 9 protons, and sodium, it has 11 protons. Isn't it? Fluorine has 9 protons, sodium has 11 protons, but fluorine's last electron is in the p5, yeah, is in the second shell, so it will be closer. Sodium's last electron is in the third shell, so it will be further away. Can you see such a huge difference in size? Yeah. Why is there a difference in size? Basically because this is in the second shell, this is in the third shell. Second shell is closer to the nucleus, third shell is away from the nucleus. Very simple. Okay? Now, what we will do is, instead of fluorine and sodium atoms, let's think of fluoride and sodium positive ions. Okay? Let's think of fluoride, F negative, okay, and sodium positive ions. Okay? Now in these ions, let's think about something very interesting. Okay? Fluorine negative ion, this has 9 protons, but it has 10 electrons now, because you've given it one extra electron, F negative. Sodium positive has 11 protons, but 10 electrons in it, because you've taken away a certain electron. Can you see? So fluorine, 9 protons, 10 electrons, and this guy has 11 protons versus 10 electrons. So, to interpret it a little better, this is one extra electron and this is one electron less. Deficit in electrons. Fine? Okay, great. Achha, people, think about it, okay? All of you are, imagine all of you are criminals and you are trapped in a room, okay? All of you and your friends are criminals. I don't know what you did, but you are trapped in a room, okay? And let's say you are 10 criminals in a room, fine? If there are 10 security guards to take care of 10 criminals, it's very easy. Every security guard can take care of one criminal. No one can escape. Yes, but now imagine that there are 11 criminals, 10 security guards. The 10 security guards can take care of 10 criminals, but one criminal is a little more free. Rishabh, I've already told that 20 times, man. Bhai, kyun, kya chinta kar raha hai? I'm teaching here over it right now, so please focus on the class. Okay? Huh? So, the security guards, 10 security guards versus 10 criminals is fine. But when you put an extra criminal, that guy can run away. That guy can run away. On the other hand, if you have 10 security guards but only 9 criminals, then the security guards can keep you locked inside the room. No one can escape because you are at a disadvantage, lesser criminals. Can you see something similar over here? 9 protons trying to take care of 10 electrons. There's one extra electron. This guy can roam around freely. Okay? The extra electron can roam around freely. It can exist a little far from the nucleus because it does not have so many security guards holding it. Yeah? Fine. At the same time, 10 electrons being guarded by 11 protons. 11 protons will keep these electrons very close. Yeah, because there is more positive charge. Yeah. So, the thing is, over here, 10 electrons, these are kept very close by 11 protons. Yeah. On the top, I would write that the number of electrons is the same in both cases. Yeah, number of electrons is same in both the cases. These two are essentially isoelectronic, isn't it? These two are isoelectronic. Isoelectronic means the same number of electrons, right? So if you have 10 electrons over here, 11 protons held very well. 9 protons only. These will be held loosely. Understood this idea? Understood this idea? F negative, electrons are held loosely. Na positive, the same number of electrons is kept very tight. Now, I'll show you a fact, and that's going to be really interesting for everyone. Can you see how much the radius has changed? 136 picometers is for F negative and 95 picometers is for Na positive. Understood the reason? 10 electrons, 9 protons only, loose. 10 electrons, 11 protons, compact. Yes. See the huge difference that is here now. Fluorine itself 64 picometers, put one more electron, 136 picometers. Sodium itself 186 picometers, of course, because 3s electron. But you take away the 3s electron, sodium positive is only 95 picometers, okay? Yeah. Mystery monster, thank you so much, man. Sarthak is saying Z star is more in the case of sodium? Absolutely, yes. It is, because you've got more protons for the same number of electrons, yeah? So over here, can you see the similarity in all of these? The similarity over here is that all of these are isoelectronic, yes? All of these are isoelectronic ions. All of these have 10 electrons each. Now, I know they have 10 electrons each, but can we talk about the number of protons in each of these cases? This has 8 protons. This has 9 protons, this has 11 protons, and this has 12 protons. What would be the order of radius over here? What will be the order of radius over here? 10 electrons taken care of by 12 protons. Very close. Magnesium 2 positive will be the smallest. Then comes sodium positive, because 10 electrons taken care of by 11 protons. Then you would have fluorine. Then you would have O2 negative. For isoelectronic species, more negative charge is higher radius. As simple as that. Fine? Just keep this in your mind. For isoelectronic ions, for isoelectronic species, more negative charge implies higher radius. That's it. Rishi is asking, is this applicable only for isoelectronic species? Yes, Rishi, because see, when you're comparing things with each other, there needs to be a commonality between them so that you can compare them. Yeah, you can't randomly compare arsenic with copper, let's say. Yeah, it's very pointless to compare arsenic with copper. So similarly, over here, the commonality over here is 10 electrons each. Okay, on the basis of electrons, now we can compare their sizes. Yeah. So whenever you're comparing things with each other, there has to be a common thing that exists between each of them. Fine. Rudransh, when electrons occupy bonding molecular orbitals, then energy is released. You will learn that in chemical bonding. Fine. Medical Insider is saying, so how to deal with backlog for NEET 2022 and not feeling really motivated. Bro, do one thing. Today at today at 9:30, I'm taking a free session on Unacademy's platform, because the chat box over there is much easier to manage. Yeah, and in that I will take these type of doubts. Okay, it's a counseling session essentially. So people, in case you want to join the counseling session, let me show you how you can join it. Just give me one moment. Technically speaking, the class is over. Okay, ये वाला class खत्म हो चुका है. You guys can chill out if you want. But let me show you how to join that session that I'm talking about. Okay, so you open today's class. Okay, today's class, you see the description box. Follow Pahul Sir on Unacademy app. You open this jazz. Okay, you open this link. You will be welcomed by my profile at Unacademy, which should open in some time. Blame the internet. Khul ja sim sim. अरे भाई कहाँ हो गया इंटरनेट को. People, there's something wrong with the internet, but yeah, that link that I showed you, just open that link. You'll be redirected to my profile at Unacademy at 9:30. I'm taking a doubt session over there. You just check it out. Okay, fine. Chalo. Now they're saying how to remember the periodic table easily. You just look for mnemonics for the periodic table. Yeah, just search for this on YouTube or Google. Mnemonics for remembering the periodic table. I'll take a quick session on these very soon. Fine. Chalo. People, that's it from my side in today's class. Thank you so much for joining in. In the next class, we will understand more concepts related to covalent radius, ionic radius, van der Waals radius, metallic radius, etc., etc. What are the different ways to define radius? And then we'll try to think about the ionization energy as well. Next class is going to be on Friday at 7 p.m. So I'm going to see you then. Until next time, take care. And if you want to join Unacademy's Plus subscription, please use the code Pahul for the maximum possible discount. Chalo ji. Bye bye people. Take care. I will see you very soon. Ciao.